In a small patch of sky, no bigger than your fist at arm's length, a single...
This is NASA's Kepler Space Telescope, launched with one audacious mission. Stare at more...
Kepler did not chase planets across the sky. It simply watched, measuring tiny dips in brightness when a world passed in front of its star.
Each dip in a star's light is a transit, a possible planet briefly blotting out a fraction of its sun's glow.
Over nearly a decade, Kepler turned thousands of those tiny dips into confirmed exoplanets, revealing that worlds are common, not rare. By the end of its mission, Kepler had discovered over 2,600 exoplanets, about 2/3 of all known planets at that time.
Those numbers led to a remarkable conclusion. In the Milky Way, there may be more planets than stars. On Universe Unlocked, we are less interested in big numbers than in a deeper question. Did Kepler find worlds that could be...
To answer that, we need to look past the gas giants and hot Jupiters and focus on Kepler's most precious finds.
The habitable zone is the region around a star where a planet could, in theory, have liquid water on its surface. Not too hot, not too cold.
Kepler 1886f orbits a small red dwarf in Cygnus.
It is only slightly larger than Earth, around 10% in radius, making it one of the most Earth-sized worlds we have ever found.
If you could stand there, the sky might glow deep red with faint daylight. But
All we know for certain is its size and orbit. Its mass, atmosphere, and surface conditions are still.
That is why astronomers call it an Earth-sized planet in the habitable zone, not a second Earth. It is a promising effort.
Kepler did not stop at one. It found multiple systems with potentially habitable super-Earths and mini-Neptunes.
In Kepler 62, two planets, 62e and 62f, sit in or near the habitable.
Its star will likely burn more steadily and for longer than our sun, giving life, if it exists there, more time to arise and evolve.
Then there is Kepler 452b, often nicknamed Earth's older cousin, orbiting a star very much like our own.
The host star is a G-type like the sun, but older and slightly more luminous, offering a familiar kind of starlight to its planet.
Kepler 452b itself is about 6% larger than Earth, likely more massive. Depending on its atmosphere, Kepler 452b could be pleasantly temperate, dangerously overheated, or more.
So what does better than Earth even mean? More stable climate? Longer-lived star? More room for life to grow?
Many of Kepler's best Earth candidates orbit smaller, cooler stars that can live for tens or even hundreds of billions of years. That long lifetime is a plus, but small stars can flare, bathing planets in radiation. For life, these systems might be both risk and opportunity, a longer window for evolution, but under... Some Kepler planets may be tidally locked, with one side in eternal day and the other in endless night.
To find these worlds, Kepler stared at a single patch of sky in Cygnus and Lyra, watching more than 105,000 stars at once.
Automated algorithms combed through years of brightness data, flagging which stars showed regular transits, each dip a whisper from a distant world. One early star of the show was Kepler 22b, a planet in the habitable zone of a sun-like star. It is more like a mini-Neptune, but it taught us that habitable zones are not just theoretical rings. They are populated with real planets.
Put together, Kepler 4180 Vetters and 86f.
On Universe Unlocked, we call them Earth candidates, not Earth twins, because honest storytelling starts with what we truly know and what we only guess.
Models show that with enough greenhouse gases, it could maintain liquid water. Without them, it might be locked in glacial cold.
Kepler 452b receives more energy than Earth from its older star, possibly.
In that sense, Kepler 452b might be Earth's future. When we talk about worlds better than Earth, we usually mean better for life in general, not better for humans walking around in shirt sleeves.
Super-Earths might have thicker atmospheres and stronger gravity, which could help hold onto air and water for longer, shielding life from space.
Some Kepler worlds may stay in the habitable zone for far longer than Earth will, simply because their stars evolve more slowly.
If we define better as more time, more stability, and more chances for life, then several Kepler
itself eventually ran out of fuel. Its pointing no longer steady enough.
Even after its original wheels failed, engineers repurposed it as the K2 mission, continuing to find planets in new fields.
Today, missions like TESS scan almost the entire sky, while Kepler's data remains a gold mine.
Reanalyses of Kepler data continue to turn up new habitable zone candidates, proving that its discoveries are still unfolding years after the telescope shut down.
Around the world, teams use Kepler's archive to hunt for planets that earlier pipelines missed, refining our count of potentially habitable worlds.
Universe Unlocked takes those numbers and turns them into stories you can actually follow, linking data, physics, and imagination.
We know sizes, orbits, and how much light these worlds receive. We do not yet know their landscapes.
It is tempting to fill those unknowns with forests and cities. But for now, life on Kepler.
The fact that we can even see these planets at all is astonishing.
While each Earth-sized detection is ensured with noise, patiently filtered by algorithms and humans looking for patterns too subtle for the eye alone.
Transit geometry, orbital mechanics, and stellar models all have to line up before we can call a dip a real planet and estimate its size and temperature.
Together, these systems show how many different ways a planet can sit in a habitable zone, close around a dim star.
Headlines often shout about new Earths, but the truth is more subtle, and honestly, more interesting than simple copies of our own world.
Our goal is to make that subtlety clear, to show you what the data really supports, and where imagination begins.
Are there planets better than Earth for life? We do not know yet, but Kepler has shown us that the galaxy is...
Each candidate is incredibly far away, tens of thousands of trillions of kilometers. But the fact we can measure future telescopes will go beyond transits, directly imaging some of these worlds and splitting their light into spectra that could reveal air and oceans.
That is where we might finally move from candidate to likely inhabited, when we see atmospheric fingerprints. Worlds like Kepler 186f and Kepler 62f are high on the wish list for those future instruments.
For students today, Kepler's worlds are not science fiction, but real destinations, places they might study.
Next time you see Cygnus overhead, remember that in a small slice of that constellation, one telescope found thousands of worlds.
Kepler tells us that our solar system is just one of billions of planetary systems.
Whether these planets are true better than Earth or not, they remind us that our world is not the only place the universe might have tried the experiment of life.
For now, Earth is still the only place we know for sure that life exists, and that makes it priceless no matter how many Earth candidates Kepler finds.
If you are watching this, you are already part of that journey. One more month.
From exoplanets and megastructures to dark energy and artificial intelligence, this channel exists to unlock the universe, one mystery at a time.
Kepler itself is now silent, but its light curves and planet catalogs are still speaking.
Each dot in that sea of orbits is a real world that dimmed its star for a moment.
More planets than stars means more chances for oceans, atmospheres, chemistry, and maybe civilizations looking back at us.
If you want to keep exploring these worlds and the physics and stories behind them, Kepler's best Earth candidates may outlast our world, or they may lifeless rocks. This has been Kepler's story. How one telescope, staring at one patch of sky,